Today we're going to talk about the Alpaca Rotator and how you can use it in NINA and Stellarium as well. The main purpose of it is to help you do better framing of your deep sky objects and also assist with mosaics and panoramas. We'll start by having a look in NINA and setting up the equipment. Go straight to the mount and do a discovery and connect up the Alpaca telescope. And now there's a new option where you can go to the rotator equipment and do the same sort of thing, do a discovery of any devices, pick the one that's best for your network and connect that. And now NINA's got full control of the rotation axis directly. And on the imaging tab of NINA, there's a little rotation icon here, tool, and that allows you to manually move position angle directly. But to be honest, I find it a lot easier just to use the Alpaca client and directly influence it. Let's start off by moving our head so that it's got a roll of 0. The roll angle is pretty intuitive. This is how much of an angle the camera is on a tilt compared to the horizon. But when you go to equatorial coordinates, the position angle is a bit more hard to understand. So the ASCOM position angle is defined in the equatorial coordinate system, where 0 degrees means that the top of the image is pointing towards the celestial north pole. And angles increase in counterclockwise fashion. There you go. Does that make sense? Let's try and use it in a practical fashion. I want to do some imaging tonight of a reflection nebula. I've got one in mind, and that is the Blue Horsehead Nebula. It's still low in the west. We should have time to get to it. We'll go directly to it now. So I'll do a query in Stellarium as well. In fact, it's already there. Zoom across. Can't really see much, but if you zoom in, you can start seeing the shape of a horse's head here. Here's the eye, here's the main head, and let's call that up in NINA as well. I see 4592. Send it to the framing assistant. And you can sort of make it out here. If we zoom in, you can see it looks upside down here, and this is where sort of understanding what this particular perspective is can be a bit confusing. But in NINA, this rotation angle here is the same as position angle over here. So in NINA, you can simply change the proposed rotation angle and you can see the framing get adjusted. Now the default view in the framing assistant has a position angle of 0. The top of this window is actually pointing towards the celestial north pole. You can change that, enable this rotation view here, and now when you change the proposed position angle, it actually changes the orientation of the image. It makes it a bit easier to see how you want to frame it. So I've actually got a orientation in mind where, if we have a look here, to zoom in a bit, the horse head, I want it up the right way. I want to have these stars out in front, so it's sort of leading the horse. And the other thing I want to do is I want to make sure that Antares up here is out of frame, because I don't want that influencing the image. I want the horse to be the primary subject, and in this framing I'll also get the mane, which comes back around here. So I think this is pretty good. I want to have a proposed position angle of 140. You can actually change Stellarium so that it shows that by going into the settings of the oculars, and I've set these up already. I've got an RF 135mm lens set up, and if you click and choose equatorial mount for that particular lens and then show it, you'll get the perspective of that particular camera. And you see here the writing's at the bottom, so the horse is actually, zoom in so we can see it again. here's the bottom of the frame, here's the top of the frame because that's towards north, it's actually upside down and it's not the way we want to actually take a picture of it. A key trick that I found out is in Stellarium you can also change the rotation angle. They call it the rotation angle here, but there's a bit of a catch. It's from a different frame of reference than the standard ASCOM position angle. So all you need to do is take the negative of the position angle, and if you put it in here, you'll get the same angle. So what I'm going to do is I'm going to put in minus 140, type that in, and bring it back to, where were we? Bring it back to the blue horsehead nebula. So about there. If we zoom in now, it's down about here. Now you can see the framing that I'm going to get. It's tilted slightly. It's got these out in front of the head, and this one up just slightly, and the main's going to be coming back this way. So that's the correct framing that I want, and I've just confirmed it in Stellarium as well as in NINA. But all you need to remember is when you're using the ocular tool is to put in the position angle as a negative number here, and then this will match what you've got in NINA, or you can just do it all from NINA. And that's all I needed to do. So I'll slew and center and rotate, and I can confirm that the image that I get from the camera is correctly framed the way I want it to be. Now, while the position angle can be confusing, the great thing about it is that it's consistent no matter where you are taking the image from. So if you frame up the Blue Horse Nebula from where you are at any time of the day, and you put in a position angle of 140, and all these equatorial coordinates remain consistent, you'll get exactly the same framing that I've got here from Sydney. So that's why we use the position angle. It's a consistent reference that we can use for framing up the images. Now, NINA also allows us to do mosaics with the assistance of the rotator. I'll switch across to the offline sky map and load that. And I'm going to go back to a position angle reference of 0. And I might change my lens to be a 35mm lens and zoom right out here so I get a good picture of the Milky Way. So what I can do now is create a tiled mosaic. Let's say make it 3 wide and 2 high, and I can adjust the position angle so I can line up how I want with the Milky Way. So in this case that line is actually, I think, the celestial equator, and this is taking 1, 2, 3, 4, 5, 6 images, and you can see here that it's calculated the right ascension and declination of each of these panels, and it's using the position angle 115 for all of them. You can actually enable preserve alignment, and that will recalculate the particular position angle at each of these individual panels so that you get a rectangular image for the whole thing. So if I did this, I should get a nice straight capture of the Milky Way across those 6 panels. I can add these to a target sequence. I'll do that now. I'll just put them into the legacy sequencer, and you can see it's added each of these individual panels with their own right ascension and declination coordinates. And in here you've got the option, if you've got the rotator connected, you can slew to that particular panel's location. You can center it with the plate solving. You can now also rotate, and if you've got a guider, you can start guiding as well. So what this does is when, after it's done a plate solve, it not only gets the right ascension and declination, it also gets the position angle, and it will correct any offset of the actual image and make minor adjustments to the rotator to correctly position that image or that panel in the sequence. Pretty powerful. One thing I did want to mention is that because the position angle and the roll angle are quite different things, it can be quite difficult to understand what's a valid range for the position angle, because it varies depending on where you're pointing in the sky. And a quick way to find that out is if you switch to the roll angle, and we'll just turn on tracking here, you can use these presets in the floating action buttons to navigate to one extreme or the other. So we can go to plus 70 degrees, which is close to the limit of where you'll get to with the second motor that allows a roll angle orientation of 70 degrees. And then you can flick back for this particular orientation at 264.28. The maximum position angle we're going to have is 188. And then you can go to the opposite extreme of minus 70 degrees roll angle. Takes a little while to get there. And come back here. And you can see that you've got a position angle pretty much from 48 degrees upwards to 188 is a valid range that you can have position angles. So that's just a little trick to find out what are the valid position angles that you can reach at that particular orientation. Anyway, I'll show you the image that I captured of the Blue Horse Nebula. I hope you like it. And that's all we've got for today. I'll see you next time. Bye.